Hello everyone, welcome to lesson 8.3/8.4. We'll see if this turns into 2 videos or if it's just one, but a lot of these radical rules, a lot of the simplifying, it kind of goes together. So these two are joined together. Again, maybe you decided to get ahead, maybe you were doing this on Friday, up to you. Please feel free to email me with questions if you have questions along the way. But in 8.3, we are continuing on with simplifying radical expressions. We're going to start with this rule. This is called our product rule for radicals. So if the nth root of a and the nth root of b are real numbers, so key thing here is you have to have the same root. If you have the same root, then you are allowed to combine the radicands and just multiply them underneath that radical sign. So if I had, the 5th root of x times the 5th root of y, that would be the same as the 5th root of x times y. But I have to make sure that those n values, the root itself, is the same. So let's go ahead and do some examples of this. So I have the square root of 7 times the square root of 5. Well, because these are both squares, there's no 2 here, but we know there's kind of a little invisible 2. I can just go ahead and multiply the 7 and the 5. So that's going to give us the square root of 35. Can I simplify the square root of 35 at all? Can I, take anything out from under the radical sign? Not really, right? 35, it's not a perfect square. That's going to be our simplest answer. So square root of 35. This next one, again, they're both square roots. They both have the same n value. So I'm just going to multiply the 31 and the x. Can't simplify that at all. So that's our final answer for B. We're going to keep going here with C. For this one, I have 3 and 3, so the same n value. So I'm going to have the cube root of 9 times 3, which is the cube root of 27. And that one, I can simplify. Cube root of 27, well, 3 times 3 times 3 is 27, so that's just going to be 3. So just be aware, sometimes you can simplify them, sometimes you can't, but just pause once you find your answer and see, okay, can I go any further with this? All right, our last one, we have 6 and 6, so I'm allowed to just multiply whatever's underneath the radical sign. I'm going to have the 6th root of 6y to the 4th times 3x to the 4th. I'd like to rearrange those numbers a little bit. I can actually multiply the 6 and the 3 to get 18. So I have the 6th root of 18, and then typically we like to write x's before y's, so 18x to the 4th, y to the 4th. I can't simplify from there. I can't pull anything out from the radical sign. These 4's are smaller than the 6, which means I won't be able to pull out an x or a y. If I had something in here that was greater than the root, then I would be able to simplify. I would be able to pull something out. You could use those rules from yesterday to help you a little bit. But for this one, can't simplify. Can't simplify. That is going to just be our final answer. All right, let's keep going with this. Again, feel free to pause, jot things down, take your time with this. So we have a product rule saying if I have 2 roots that have the same n value and they're real numbers, I can multiply them similarly. If these are both real numbers and if this is not going to be 0, then I'm allowed to use this rule right here. And you can use this in either direction. I could have the 5th root of x over the 5th root, keep drawing this weirdly, of y. I could combine that to be the 5th root of x over y, or you can use the rule in this way. Maybe you have a fraction underneath your radical sign. You can separate those out. Again, we've been kind of doing this already. We've been secretly kind of doing this, thinking this through, but this is your official quotient rule for radicals. You are allowed to, as long as they have the same root value, as long as they have the same index, we call n the index, then you are allowed to separate into 2 separate roots. All right, 4 examples for this one. So here I'm going to separate this. Again, you guys actually have done some problems like this. This is just the official rule. Rad 36 over rad 49. Well, rad 36 is just 6. Rad 49, that's just 7. That's your answer over there. So before we had to kind of think through, hey, do I have any fraction that when multiplied by itself gives me 36 over 49? This way I think is a lot simpler. This root rule is really nice. All right, for this next one, let's split these up. I have radical x over radical 16. Can I simplify that at all? Radical x has to stay as it is, but root 16, that's the same thing as just 4. All right, down here, cube root of 27 over the cube root of 64. Can we simplify those at all? Well, cube root of 27, we just said that a couple minutes ago, 3. What about on the bottom? What number multiplied 3 times equals 64? It's just going to give us 4. And again, you can always check by doing the reverse process, right? If we were taking the cube root of 27 over 64, then I could cube 3 over 4 like this and make sure that I'm getting 27 over 64. So this is just your little check if you ever want to make sure you're doing the right thing. All right, our last one over here, we're going to separate this into the 4th root of 4 over the 4th root of 81y to the 8th. Okay, this looks a little more complicated. Up top, is there any number when multiplied 4 times equals 4? Not really, no. And you could also use your factor method and split 4 into factors. Well, I would only get 2 and 2. I would need a number to show up 4 times to simplify. So up top, this is just going to be the 4th root of 4. But on the bottom, I actually can simplify this. So let's start with 81. If I use my factor method, well, 81 is the same as what? 9 times 9? 9 splits up into 3 and 3. The other 9 splits up into 3 and 3. Oh, cool. Fully factored, I'm getting 3 times 3 times 3 times 3. So the 4th root of 81 is just 3. And then for this other one, I'm going to actually rewrite this separately over here. The 4th root of y to the 8th, let's use one of those rules from yesterday and rewrite this as the y to the 8 over 4. That's the same as y squared. So we can successfully simplify the 4th root of y to the 8th as just y squared. And that, folks, is your final answer for that one, okay? So just take these step by step, similar to when you guys were simplifying those really complicated, complex exponents a couple weeks ago. Just take it step by step. Break this up using your quotient rule or using your product rule, and then simplify as you go. All right, another example for us. We're going to simplify the following over here. So you guys, I gave you some problems like this because I know that you've done some of this, like you've dabbled in this in other classes, you've kind of had to. But for this, we're going to see how we've been secretly using that product rule all along. So root 40, I can split that up into 4 times 10. That would be the same as radical 4 times radical 10. Radical 4, the square root of 4 is just 2. Square root of 10 is just 10. So this is kind of using that product rule in reverse to simplify. If any of you have taken classes with me before, not many of you have, a handful of you have, maybe in geometry. I like to sometimes refer to this method as like the greatest perfect square method, right? I'm trying to see, hey, what factor in 40 is the greatest perfect square? Think in terms of numbers like 4, 9, 16, stuff like that. We're looking for a perfect square. 4 is our greatest perfect square factor, so that's why I split this up into a factor of 4 and 10. It just is a really nice way to simplify these problems. All right, what about the cube root of 135? So here I'm looking for the greatest perfect cube. You might want to test some things out, try some things in your calculator. So some perfect cubes would be 8, 27, 64. Try dividing 135 by some of those and see, is it a factor? We can split this into 27 times 5. Well, our product rule says I can split that further into cube root of 27 times cube root of 5. Cube root of 27 we already know is 3. So we have simplified the cube root of 135 to 3 times the cube root of 5. What about square root of 15? So the only factors that I could split that up into are 3 and 5. Neither of those are perfect squares. So because we have no perfect square or cube or whatever factor here, the radical is already simplified. So we're just going to leave it alone as square root of 15. The radical is already simplified. So we just leave her alone. Square root of 15. All right. Good work, folks. We have 2 more examples in 8.3, and then I think I'm going to stop and start the next video so you're not watching this for 47 hours. All right, example 4. Use the product rule to simplify. So now I'm dealing with numbers and x's. Again, you kind of did some sort of kind of like this the other day. We're just applying this specific rule now. So over here, I have the square root of 36x to the 7th. I want to split that up into some terms. So 36 is a perfect square. I love that. But also x to the 7th, I would like to factor that into some term that has an exponent that is a multiple of 2. So I'm going to split it up like this. 36x to the 6th times the square root of x, okay? So what we did here was we split x to the 7th into x to the 6th times x. Why did I do that? I wanted to split this up and have the largest factor that had an exponent of 2 because I'll be able to simplify the square root of x to the 6th pretty easily, okay? So we're looking for our largest factor that I know I'll be able to like simplify perfectly. So this first term, square root of 36x to the 6th, well, square root of 36 is just 6. Square root of x to the 6th, again, on the side, I'm going to rewrite that as square root of x to the 6th is the same as x to the 6 over 2 is the same as x cubed. So this whole first term just becomes 6x cubed, and then the square root of x can't really do anything with her, so we're going to leave her alone. This is your simplified version of that, all right? So when we say simplify, we're just trying to see, hey, do I have anything that I can pull outside of this radical sign? That's what I mean by simplify. All right, let's take a look at B. I'm going to erase some of this so it's not in the way. All right, cube root of 54, x to the 6th, y to the 8th. We want to think along similar lines here. 54, is that a perfect cube? No, but does it have a factor that's a perfect cube? Well, yeah, 54 I can split into 27 and 2. So I'm going to rewrite this like this. Cube root of 27 times 2. X to the 6, well, 6 is a multiple of 3, so that'll actually be able to simplify quite nicely. So I'm going to leave x to the 6th as is. Y to the 8th, well, 8 is not a perfect multiple of 3, so I would like to split y to the 8th up into 2 factors. Y to the 8th, I could split up into what number is less than 8, but is the largest multiple of 3. Well, 6 would have to be that number. So I'm going to split this into the y to the 6th times y squared. So y to the 6th times y squared. All right, stick with me here. Now I want to separate out the things that are perfect cubes into their own cube root. So cube root of 27 x to the 6th, y to the 6th times everything that was left over, cube root of 2y squared. This whole first part will simplify nicely for us. So this step right here, that is us using our product rule. I had a bunch of things multiplied underneath the radical sign. I separated them and made sure they both had the same end value on the radical sign. Cube root of 27 is 3. Cube root of x to the 6th would be x to the 6 over 3, or x squared. And cube root of y to the 6th would be y squared. Over here, I can't simplify anymore, so we're going to leave that alone. This is your simplified answer for part B over there. So again, pause, go back, watch other videos on YouTube, watch other examples on Delta Math to help you figure out some of these things. We're going to move on to our final example for 8.3. Here we are using our quotient rule to simplify. So over here, if I have two things that both have the same index, so I have a sneaky little 2 here, sneaky little 2 here, this is going to be the same as the square root of 72 divided by 2. Well, what is 72 divided by 2? Hopefully you are shouting loudly that it's 36. Square root of 36 is just 6. All right, so that's our application of our quotient rule. We are rewriting it as so. We will be able to simplify it a lot easier in that way. Okay, this one looks complicated. Break it down. Take it step by step. I have 4 times the cube root of 56 x to the 5th, y to the 8th. So again, what I'm noticing here is x to the 5th, y to the 8th, those are both larger than the index out here, which means I will be able to simplify and pull out some x terms from under the radical sign. Okay, so what we need to do here, I'm going to erase those. What we need to do here is factor some things, opposite of what I wanted to say, is divide some things. So I have 4, and then because I have a cube root here, I can combine these and say 56 x to the 5th, y to the 8th over 7y squared. You guys know how to simplify this at this point. Oh, I forgot my little cube root here. 4 cube root, well, what is 56 divided by 7? That's 8. I only have one x term, x to the 5th, so that just stays alone. Y to the 8th, over y squared, what would that simplify to? Y to the 6th. Nice. Okay, so we're already doing well here, but I can keep going. I can keep simplifying that cube root a little bit. So we still have 4 out front. I am going to try to separate out these x terms. Again, for x to the 5th, how could I split that into factors where one of the factors is a multiple, has an exponent that's a multiple of 3? Well, I could split this up into x to the 3rd times x squared and y to the 6th. That one is a multiple of 3. So honestly, I don't even need to split that one up. So we're going to rewrite this as follows. 8x to the 3rd, y to the 6th times the cube root of x squared. Okay, so all we did, 8 is a perfect cube, y to the 6th is the perfect cube. I split this x to the 5th into a perfect cube factor and the other factor. Okay, and then here we're using both our quotient rule to go from this step to this step, and here we're using our product rule to split things up a little bit. All right, 4 times cube root of 8 is 2. Cube root of x cubed is x. Cube root of y to the 6th is y squared. And then I have to leave alone this little cube root of x squared. Our final answer here, folks, 2 times 4 is 8xy squared, cube root of x. That is your fully simplified version over here, okay? So again, whatever we can pull out from under the radical sign, we want to do that. And you have a couple different rules that you can now use. And then any other terms, I still might have things left, or you might have cases like part A where it beautifully, perfectly simplifies, okay? You will have some different versions that pop up. All right, I will see you guys in video 8.4.